Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we're going to just keep going in chapter number 8. We will be on page number 279. That is chapter 8.2, Removing Perfect Square Factors. This is actually one of my favorite lessons. I like this lesson. This is a fun lesson for me as a teacher. Hopefully you enjoy this lesson too. It's kind of like a puzzle, and it's like figuring out how the puzzle works together. And I find it very satisfying when you get it, when you finally like it clicks and you're like, I know how to do that now. And it's pretty fun to watch. So let's jump into it. We are on page 279 and we're going to start with what's called the product rule for radicals. In the product rule for radicals, we have to understand that just like the product rule for exponents, just like the product rule for anything, we're talking about multiplication. So when we have something times something else inside the radical sign, like for instance, if I have 3x, well, I have 3 and x inside there. What is that? That's a multiplication. That is going to equal 3 times x. Square root of 3 times square root of x. In other words, just like with the quotient property, what I can do is I can break that down into two separate multiplication problems. Well, this kind of works with different things. Like, for example, if I have something inside of there, like, let's say the number 8. Well, technically, the number 8 has factors, doesn't it? So if I break that number 8 down into factors, I could say that that equals the square root of 4 times the square root of 2. Why? Because 4 times 2 equals 8. Okay, what did I do there? I just broke down the factors. Just like I broke down the factors of 3x. 3 is a factor, and x is a factor. Well, what are the factors of 8? 4 and 2. Okay, now 1 and 8 are both factors of 8, but that doesn't really do us anything. So we could actually say 8 equals the square root of 8 times the square root of 1. That doesn't do us anything because the square root of 1 is 1. 1 times the square root, it doesn't change anything. The only time that you're going to use this is when you have factors other than 1 in itself. So, like if I have a prime number inside there, it's not going to do me any good to factor that. The only time I'm going to want to factor that is when I have more than one factor that will pull out. Okay, so the reason why you want to do this is because maybe you notice something happened right here. What happened right there is I got a perfect square. I can now solve that. What is the square root of 4? Well, it's 2. 2 times the square root of 2, or you could just write it 2 square root of 2. You don't have to write the times sign. And that would be my answer for that problem. Okay, how did I get the answer? Well, what is this called? What am I doing here? What I'm doing is I'm simplifying this square root of 8. Is there a perfect root for the square root of 8? No. Okay, so if we go to our calculator and you type in the square root of 8, so I hit 8 and then I go to my square root, I get 2.82842. This is irrational. Square root of 8 is irrational. So how do I simplify it? Okay, well, the way that I simplify is I take out, if I can, what's called a perfect square. I've never heard this referred to by anybody else except for me, so I'm going to call it a Mr. Steveism. That's a word that I created. Okay, we are going to do what's called square factoring. And what is square factoring? Square factoring is using our square numbers to factor. We're not concerned with, the book doesn't show you this. The book shows you prime factoring, and I get prime factoring, but I want you to understand, I want you to do what I'm calling square factoring. What does that mean? Here's what it means. I'm going to take all of my perfect square numbers and I'm going to use those only. Okay, what are the perfect squares? Well, obviously 1 is a perfect square, okay? But we don't need that one. That one's not going to help us. The first perfect square is 4 because the square root of 4 is 2, right? What's the next one? 9, 16, 25. These are the ones from your list. Remember I told you to memorize these? These are the ones back in chapter 1 on table B that you should have memorized. 36, 49. We'll stop right there for now because I don't need to go any higher. Why not? Because my number is lower than 49. My number is actually lower than 36. So it can't be one of those. That's not going to work. How do I figure out which square factor to use? Well, I always start with the biggest one, and I say 49 is not going to work because it won't go into 36 won't work because it won't go into 32. 25 doesn't go into 32. Here's what I'm looking for. I'm looking for a number that will divide into that evenly. 16 goes into 32 evenly. Look what I get. I get the square root of 16 times the square root of 2. Why did I do that? What was the goal here? My goal is to simplify this number to make it smaller. Look what happens here. I have a 16. What is the square root of 16? Well, it's 4. And then I still have my square root of 2 left. So the simplification of this square root of 32 is 4 square root of 2. 4 square root of 2. How did I get that? I wrote down my perfect squares. Where did the perfect squares come from? The list I told you to memorize in the last lesson. Did you memorize it? Yeah, I didn't think so, okay? So go back and memorize it now, okay? You need it, okay? I didn't tell you to memorize it for fun. I told you to memorize it because you're going to need it. So here we are using it. All right, let's go to the next one. All right, so we're going to use our square factors again. Let's go ahead and write them down again. I'll write them down. This will help you to memorize them. Our square factors are 4, 9, 16, 25, 36, 49, 64. I think we can probably be done right here, but we'll keep going. 81, 100, and 121, and 144. Okay? Now, remember I always said start at the biggest one. Like when you're prime factoring, you start at the smallest one. But we don't want to start at the smallest one. And I'll tell you why later we don't want to start at the smallest one. But just trust me right now, okay? And I'll show you why that's true later as we continue to work on these throughout this lesson, or throughout this chapter. So let's start with 144. Does 144 go into 252? Well, you just do it. I mean, if you need to, go to your calculator and just type it in. Type in 252, 252, divided by whatever your number is here, 144. Does that go in evenly? No, it doesn't, 1.75. Then you just keep going down your list. 252 divided by 121. Does that go in evenly? No, it doesn't, 2.08. That was pretty close, but it didn't work. Well, 100, we already know 100 won't go into it because I can do that in my mind. 81, does that go into it? I don't know. I don't think so, but we could try it. 252 divided by 81 equals 3.11. No. All right, let's try the next one. 252 divided by 64 equals 3.9. No. Try it again. 252 divided by 49 equals? Nope, still not. Still haven't found one. 252 divided by 36 equals. Hey, we got one finally. It equals 7. So what you're going to do is you're going to say, okay, well, all of these didn't work. Okay, 36 works. So what do? You come back over here and you do 36. Don't forget, it's the square root of 36 that we're using. And what did we get when we divided it out? We got 7. Okay? Now what can we do? We can solve out the 36. What is the square root? Why did we use this? Because they have perfect roots. That's why we use those numbers. What is the perfect root of 36? It's 6 Square root of 7, that would be your answer. Okay? Let's do another one. That's fun, right? You having a good time? All right. You're not? Okay. Well, I am. I like this lesson, so hopefully you do too. Hopefully you're like, oh, I like this. This is cool. And it is. It's kind of like a puzzle once you figure it out. I'm just going to go back to these numbers. I'm not going to write them all out again. So 7. Now we have, look, we have a number outside here. What is that number doing out there? I don't know. What is he doing? Well, he's just hanging out, just chilling. And so we're going to have to deal with him later. But for right now, let's just leave him alone. Okay, let's leave him alone. Let's focus on 54. So let's go back to our list and let's find a number. Well, 54, you can start with 49. It doesn't go in there because obviously it can't be bigger than the number. It won't go into it if it's bigger. 36 doesn't go into it. 25 doesn't go into it. Does 16 go into it? 16 go into 54. Okay, no, 16 doesn't go into it. Does 9 go into it? 9 into 54? It does. 9 times 6 is 54. So 9 times 6. Now remember, I always start with the bigger one. Don't start with the smaller one because maybe 4 goes into it too. But we don't want the 4 because that means if we get the 4, we might have to continue to simplify it again. So 4 might go into 56, and it does, or 54. It doesn't, but it might. You might get one that it does. And so, but always start with the bigger number. Trust me on that. You're going to want to start with the bigger number. Now is where we have to remember the 7 out front. So if I put my 7 out here, when I pull this out, what do I do with this? So what am I pulling out? Well, 3 times 3. So the square root of 9 is 3. What do I do with this 3? Well, what do you think you do with it? There's no sign, so what do I do? When there's no sign, what do I do? Okay, right, I multiply. 21, and then this is left over, square root of 6. So 3 times 7. Why the 3? Why 3 times 7? Because the square root of 9 is 3. Take the 3 out. 3 times 7, 21. What's left over? Square root of 6. 21 square root of 6 is my answer. All right, 12x squared. Well, this one's going to be easy. Wait a second. What's going on? I have an x squared under there. It's okay. Don't worry about it. Watch this, okay? I showed you this at the beginning. I want you to separate this out, and I want you to say the square root of 12 times the square root of x squared. Take the number. We're going to do the number separately. Take the letter. We're going to do that separately. So let's go ahead and do the number. Well, that's easy. 9 doesn't go into it. 4. 4 is the only option that's possible. And 4 is a perfect square. So 4 goes, and it goes 3. So 4 times 3. What comes out? 2. Square root of 4 is 2. 2 square roots of 3. What happens to this? Well, what is the square root of x squared? X is x times x. So this comes out to x times x, right? So what comes out? The x comes out, and nothing stays in. Basically, that just comes out. X comes out. So I don't have anything left over. So now we're going to put these back together. We're going to scrunch those back together. So how would I do that? Well, the x goes here with the 2. So 2x square root of 3. This one doesn't have anything. So that's it. 2x square root of 3. All right, here we go. This one, now, we have a perfect square right there. Interesting. So we don't even have to divide that one out. So when we do 25 and x cubed, 25 just solves out. It's just 5. That one's easy. Nothing to do there. Now, watch this one. What can we do here? We need to turn this one into a perfect square. So that's our perfect square. So there's the 3. And so this is going to be 2 plus 1 is 3. We broke that down into perfect squares. This is not a perfect square. This is a perfect square. This is not a perfect square, so that's got to stay in. What comes out? Well, x comes out. X, the square root of x squared is x. And then what stays in? X stays in. So we have an x that stays in and an x that comes out. We add it to the 5. We combine it with the 5. So we have 5x square root of x. That would be our answer there. Okay, for some students, this is challenging concept right here. Okay, you don't really get that at first. So let me promise you something. You're going to have to figure this out. This is all through the rest of algebra and algebra 2 and pre-calc and whatever you do. You have to be able to solve out exponents. You have to be able to reduce those exponents out of radical signs. So make sure that you spend the time right here and figure it out. Rewind that video if you didn't understand anything there. Let me do one more, and then we'll be done with this lesson. So let's go ahead and break this out. Let's take the 32 out. Let's take the x cubed out. And let's take the y squared. All right, so there we go. We got 3 different things. So we basically just took that and divided that up into 3 different problems. What comes out of this? Well, let's talk about it. Let's start with the biggest one. 36, no, it's too big. 25, no, it doesn't go into it. We've already done this one, actually. 16, so 16 goes in there, and that goes 2 times. 2 times 16 is 32. What comes out of there? The 4. What stays in? The 2. We just did this one in the previous one. X squared and x. Okay, what comes out? X comes out. What stays in? X stays in. This one we don't really have to do anything because this is a perfect square. It just comes out to y. All right, so now we put all those back together. We scrunch them back together. And what do we get? Well, outside we get 4x. Inside we get 2xy. And that's as simple as we can get that one. All right. Hopefully you got it. If you didn't, you might want to go back and watch those again. Try to slow it down. Take your time as you're watching me practice some of the exercises that are in the book. Okay, and that way you can practice it yourself. Make sure you got your pencil in your hand, that you're doing the work, not just watching the video. Be an active learner on this stuff, and I think it will help you out a lot. Okay, again, hope you learned something today. That's all I got for you. Have a good one. Bye-bye.